Good morning, student. This is the lecture number 22 of unit number 3. In that, we have started with the second part, that is strain measurement. In strain measurement, we have studied what is strain, what are the characteristics of the strain measurement, then classification of the strain gauge measuring devices. Okay. In the last lecture, we have completed the derivation for gauge factor. Okay, and we have studied or calculated the two numericals on the basis of this relation, that is f equal to 1 plus 2 times mu. Okay, it is nothing but the gauge factor relation. Okay, so today we are going to study the ballast circuit or ballast gauge circuit. Okay, so basically in the diagram you can observe that there are various components are uh, combined circuit. Okay, in a parallel or series connections. Okay, where R, capital R, is the resistance of the unstrained gauge. RB is the ballast resistance. That Vs is the input or supply voltage. VO is the output voltage, and epsilon is the strain produced. Means uh, that strain we will have to calculate. Okay, uh, that ballast circuit works on the Ohm's law. We know that Ohm's law is nothing but that V equal to IR. V equal to IR can be represented in different forms, that V equal to IR, or I equal to V by R, or R equal to V by I. Okay, likewise we can means that Ohm's law is represented in different forms. Okay, means as per as the requirement, we can prepare, or what we can say that create the relation between three parameters, that is voltage, current, and resistance. Okay, so according to the Ohm's law, the supply voltage is given by Vs equal to capital I, that is current in bracket, R plus Rb, that R is the resistance of the unstrained gauge and Rb is the ballast resistance. Okay, so here that Ohm's law or the relation is again transformed to one another relation, that is I equal to Vs by R plus Rb. Okay, that is equation number 1. Now we will study case wise when there is a no strain and when there is a stress. Okay, so in this condition, case 1 is employs when no stress is applied, means there is a uh, no stress is applied in the circuit. Okay, or resistance. To strain gauge, the output voltage is given by VO equal to I into R. Okay, so VO equal to R by R plus RB into Vs. What, how this come out to be? Okay, so here uh, according to the Ohm's law, we have sorry already calculate I equal to Vs by R plus Rb. Okay, so here VO equal to I into R. So instead of I in the equation, we have put equation number 1. That's why the equation 2 will become VO equal to R plus, means R already present in the previous step, so R upon R plus RB into Vs. Okay, initially it was VO equal to Vs upon R plus RB into R, but we can represent it likewise, that VO equal to R upon R plus RB into Vs. Okay, so these are the simple relations. You have most of the time gone through it. Okay, that's why you will understood very easily. Okay, then case 2, when the gauge is strained. Okay, when the gauge is strained, the output voltage is given by gauge resistance change from R to R plus dr, means there will be strain is there. So what will happen, the original resistance will change to R plus dr, means there will be some deformation or what we can change in resistance will take place R plus R dr, and the output voltage becomes VO to VO plus DVO. Okay, so equation 2 becomes, what is equation 2? That is VO equal to R upon R plus RB into VS. तर आर काय होईल म्हणते आर प्लस डी आर, मीन्स इक्वेशन 2 मध्ये आरच्या जागी काय येईल आर प्लस डी आर, आणि डिनॉमिनेटरमध्ये आरच्या जागी काय येईल आर प्लस डी आर प्लस आर बी. ओके, अँड व्ही ओ इक्वल टू काय येईल व्ही ओ प्लस डी व्ही ओ. So likewise it will be written here VO plus DVO equal to R plus DR upon R plus DR plus RB. There is no need to represent the bracket in the denominator. So the equation 2 becomes VO plus DVO equal to R plus DR upon R plus DR plus RB into VS. Okay, so what we have done here, that VO we have transferred to right hand side. So DVO equal to R plus DR upon R plus DR plus RB into VS minus VO. Okay, so here what we can do, we can do one thing, that DVO equal to R plus DR upon R plus dr plus rb into vs minus now that vo in the previous equation, here we can observe vo equal to काय आहे r upon r plus rb into vs. तर ही जी vo ची व्हॅल्यू आहे ती आपण पुट केली या ठिकाणी vo च्या ठिकाणी. ओके, सो vo is replaced by r plus r plus means r upon r plus rb into vs. Okay, so the next step will be dvo equal to just cross multiplying, we will get the equation in terms of vs. Okay, so dvo equal to, next step, dvo equal to dr into rb upon r plus dr plus rb into r plus rb into vs. Okay, so it implies that dr into rb upon r plus rb bracket square. Okay, from that we can write r plus rb bracket square into vs, since dr is very less than r. Okay, so dv equal to dr into rb upon r plus rb bracket square into vs. Okay, so in this equation what we have done, we have multiplied and divided by capital R. So it is means there will be no effect of R, because R will get cancelled out. So here we can write down dr in the numerator and capital R in the denominator. So dr by R, and that R into RB upon R plus RB bracket square. So we have converted the relation in the form of dvo equal to R into RB upon R plus RB bracket square into dr by R into Vs. Okay, so by applying the condition of maximum sensitivity, R equal to RB, so equation 3 becomes dvo equal to see in equation 3 whatever the R present in the multiplication of RB, that RB will be replaced by R, means R into R will be R square, and in the denominator R plus RB. So suppose we have replaced RB by R, so it will be twice R bracket square. Okay, and dr by R into Vs equal to what will come out, that in the new denominator 2r square. So suppose we have separate out 2 square and r square, then 2 square will be 4, means equation will 1 by 4 into dr by r into Vs. Okay, so dvo equal to Vs by 4 into dr by r. Okay, dvo equal to vs by 4 into dr by r. As a gauge factor equal to dr by r upon epsilon. Okay, so we can write as a instead of dr we can write f into epsilon. So dvo, that output voltage, change in output voltage, equal to vs upon 4 into f into epsilon. Okay, so it is observed that the change in output voltage when the gauge is strained is directly proportional to strain. Okay, so here in the equation, red color rectangle you can observe. So in that, f multiplied by s is written, but that is not s, it is epsilon. Okay, so from that equation we can say that change in output voltage dvo is nothing but the change in output voltage, and when the gauge is strained, which is directly proportional to strain, that is epsilon. Okay, so on the basis of this, derived from of change in output voltage equal to supplied voltage upon 4 into gauge factor f into epsilon, we have to solve the numericals. Okay, so here the first numerical is on the strain gauge circuit. Use a strain gauge of 120 ohm resistance. Strain gauge circuit means capital R equal to 120 ohm and gauge factor 2, that is f equal to 2. When the working under maximum sensitivity condition, the current flows through system is limited to 20 milliammeter. So 20 milliammeter will convert it to ammeter, that is 20 into 10 to the power minus 3, 10 to 10, 20 into 10 to the power minus 3 ampere. Okay, so calculate the supply voltage, change in output voltage when the strain of 500 micron. Okay, so strain equal to 500 mu strain means 500 into 10 to the power minus 6. Okay, so what we will have to calculate, that is supply voltage and change in output voltage. So we know that the current flowing through the system is given by current I equal to vs upon r plus rb. Okay, suppose that r is equal to rb, so we can write vs upon 2r, vs upon 2r. The supply voltage vs equal to I into 2r, means we can write supply voltage in previous equation, vs equal to current into 2r. So current is 20 into 10 to the power minus 3, r is 120, so we can write 20 into 10 to the power minus 3 into 2 into 120. Okay, so vs supply voltage can be written as 4.8 volt. Okay, so next what we will have to calculate, that is output voltage. Change in output voltage is dvo equal to vs upon 4 into f into epsilon. So vs, now we have calculated 4.8 upon 4 into that gauge factor 2 and epsilon, that is 500 into 10 to the power minus 6. Okay, that is 500 microstrain. Okay, so output voltage dvo equal to 1.2 into 10 to the power minus 3 volt equal to 1.2 micro volt. Okay, so likewise we can calculate this output voltage and supply voltage. So this numerical is asked for the 5 to 6 marks in the university exam. It is summer 14 and winter 12. Okay, so simple numerical, only two step numerical, which is asked for the 6 marks. Okay, then next, a single strain gauge having resistance of 100 ohm and gauge factor of 2 is mounted on a steel cantilever beam and connected in series with 100 ohm ballast resistor and 12 volt battery, means 12 volt battery means vs equal to 12. The bending stress at gauge fluctuates from 0 to 19.62 into 10 to the power 8 Newton per meter square. Means stress is given sigma. Okay. Assuming modulus of elasticity capital E equal to 20.6 T into 10 to the power 10 Newton per meter square. Compute the variation. Compute the variation in output voltage. Means what we will have to calculate the output voltage. Change in output voltage we will have to calculate. So which relation we can use first? That is Young's modulus capital E equal to stress upon strain. So stress directly given to us 19.62 into 10 to the power 8. Young's modulus capital E also given 20.60 into 10 to the power 10. So what we can write strain as dl upon L. So therefore strain or dl upon L equal to 0.952 into 10 to the power minus 2. 0.952 into 10 to the power minus 2. Okay. So when strain, the change in output voltage is dVo equal to, that dVo we will have to calculate. So dVo equal to Vs. Vs is directly given to us, which is uh, 12 volt. So 12 by 4 into amp, gauge factor is 2. Then epsilon strain already we have calculated, that is 0.952 into 10 to the power minus 2. Okay. So we will come out to be dVo, that is change in output voltage, equal to 0.057 volt, that is 57 millivolt. Okay. Means 0.057 volt, or it may be written as 57 into 10 to the power minus 3, means 53 millivolt. Okay. So here you can understood how or what is the ballast circuit, how it will be used in no stress condition and strain condition. Okay. Then how we have derived that change in output voltage equal to Vs upon 4 into app into S. Instead of S, that S is not in that equation, there is a correction, which is epsilon. Okay. dVo equal to Vs by 4 into app into epsilon. Okay. So on that derived form expression we have solved two numericals. Okay. In first numerical we have calculated the change in output voltage. In second numerical also we have calculated the change in output voltage. The uh, next circuit we will have to understood, that is Wheatstone B circuit. That Wheatstone B circuit you have studied in 12th standard also. In Wheatstone B circuit there are four limbs of resistances. Okay. So there are two ways of using Wheatstone bridge technique, that is null or balanced condition and deflection or unbalanced condition. So first we will go with the circuit. So in that circuit you can observe that there are four resistances are there from clockwise left side clockwise, R1, R2 and R3, R4, and in between that there is one galvanometer. Okay. So figure 3 shows the null mode of Wheatstone bridge circuit, where R1 equal to strain gauge transducer, R2 equal to variable resistance, and R3 and R4 is the fixed resistance. Means R1 is the strain gauge transducer, means strain is applied on in the R1. Okay. And R2 is the variable transducer, means R2 will variable or it will varies. R3 and R4 are the fixed resistance, and in between that there is a capital G in the circle, which is galvanometer. Okay. So when the output current flows through the limb AB and AD, when the supply voltage is given. Okay. Then when first case is when no straining, the resistance are so arranged that the voltage at B equal to the voltage at D. voltage at B is equal to the voltage at D, and the galvanometer gives zero deflection. Galvanometer काय करेल zero, means as there is no strain, so the galvanometer current will flow through the at B equal to the voltage, means whatever the voltage at B, which will be equal to the voltage at D, and the galvanometer gives zero deflection. Okay, so that is no current is indicated on the galvanometer connected between the bridge point. Okay, uh, for which R, means we can write R1 upon R2 equal to R3 upon R4, for which we can write R1 upon R2 equal to R3 upon R4. Therefore R1 equal to R3 by R4 into R2, for which we can write R1 equal to R3 by R4 into R2. Okay, so when strained, the resistance R1 changes by an amount dR1. When strained, the resistance R1 changes by an amount dR1, as it is a transducer resistance. Okay, so R1 changes by an amount dR1 when there will be strain condition in the resistance. So this change would unbalance the bridge resulting into deflection of galvanometer. म्हणजे हा जो चेंज झाला आहे की R1 जो होता तो dR1 झाला, तर this change would unbalance the bridge resulting into deflection, resulting into deflection of the galvanometer. The balance is then regained by adjusting the variable resistance R2 by an amount dR2. Okay, the balance is then regained by the adjusting variable resistance R2 by an amount dR2. The rebalance condition gives, and that rebalance condition is R1 plus R2. Means in the circuit you have observed that R1 is the transducer and R2 is variable. So whatever the strain condition is appear in the R1, which will be balanced by the variable resistance. So that's why whatever the change in the R1 to dR1, it will be appear in the R2 plus dR2. Okay, so equation can be written as initial equation is R equal to R2 into R3 by R4. So by the change in resistance of R1 and R2, it will be written as R1 plus dR1 equal to R2 plus dR2 into R3 by R4. Okay, so here that R2 multiplied by R3 by R4 plus dR2 multiplied by R3 by R4, is it? And therefore R1 plus dR1 equal to R plus dR because we know that R1 equal to R2 into R3 by R4. So here we can observe one thing. Yes, R2 multiplied by R3 upon R4 is nothing but R1. So R1 plus dR2 into R3 by R4. So that gives dR1 equal to dR2 multiplied by R3 by R4, because in the previous step that gives what is the equation dR1 equal to dR2 into R3 by R4. How it is come out to be in the previous step? See, R1 is cancelled with R1 on the right side. This left R1 is cancelled out with right R1. Okay, so that's why dR1 equal to dR2 into R3 by R4. So it will be equation 2. Okay, so if the resistance of all limbs of Wheatstone bridge circuit are equal. So R1 equal to R2 equal to R3 equal to R4 equal to R. Okay. So then from equation 2 we can write down dr1 equal to dr2. So the change in resistance dr1 in terms of strain is given by dr1 equal to f into epsilon into r. Therefore dr2 equal to f into epsilon into r. So equation 3 indicate that the change in value of resistance R2 is direct measure of strain, because here also the same mistake is done. Epsilon is represented in terms of S, but it is nothing but epsilon. Okay, so that's why the change in value of resistance R2 is direct measure of strain. Okay, so this is the null condition. Second condition we will study in the next lecture. So whatever the doubts you have in the current lecture, that we will discuss in the Google Meet. So I think you have understood all. You will understood all the things, because just simple mathematical relations are there, and that you have gone through number of times. Okay, so here we will stop.